Hey guys, I hope you did well in your quiz. We are going to move on to the next section. So this one talks about finding the volume of spheres. The set of all points in space that are a fixed distance from a given point, called the center. That's what a sphere is. You guys have all seen spheres before, all right? The Earth is a sphere, a ball. This one's baseball, this one's a soccer ball, doesn't matter. The gumballs that are here, all of those are spheres. You guys have definitely dealt with those in your life before. You also know what a radius is. The radius of a sphere connects the center of the sphere to any point that's on the sphere. So instead of taking the center of a circle and connecting it to the edge of a circle, this radius starts at the center of a sphere and goes to the edge of the sphere. A hemisphere, which I'm sure you guys have probably dealt with before also, is just half of a sphere. Cool? So, the volume of a sphere with radius r is V equals 4 over 3 pi r cubed. Nice and easy, all right? Then, when we look at the volume of a hemisphere, we're just going to take the volume of a sphere and cut it in half. So V equals 1/2, and then it's 4/3 pi r cubed. It's nice and easy. Once you have the radius, it's all just plug it in from there and get an answer on your calculator. All right? So we just have a couple examples that we are going to do today. So take a look at number 1 right there. I'm going to zoom in a little bit so you guys can see a little bit better. All right, cool. This one here, we're given the diameter of the sphere. So the diameter is 10. That means that the radius of our sphere is actually 5 centimeters. So you want to make sure that you're always careful to use the radius. And volume is going to equal 4/3 pi r cubed. And we're just going to plug it in. 4 over 3 pi times 5 to the 3rd power. Plug it all in your calculator, guys. When you do, you will get 500 over 3 pi. The pi can go on top or at the end of your fraction. It doesn't matter, but just not on the bottom. And then you need your units, centimeters cubed. If you want to go ahead and put it in your calculator, you can. Since there's not much else going on, you can leave it exact. You guys know I like exact answers better. But if you want to put it in your calculator and get a decimal, it is 523.6 centimeters cubed. And that's it. It's as easy as that, you guys. Let's look at number 2. Number 2 is a hemisphere, right? It's a half a sphere. So we know that the volume is going to be 1/2 the volume of the sphere, so 4/3 pi r cubed. And in this case, we are given the radius, right? It starts at the center and goes to the edge of our sphere. So our radius is 4. So volume equals 1/2 of 4/3 pi times 4 to the 3rd power. And again, you guys, I am totally okay with you just plugging that into your calculator. And when you do, it's going to spit out 128 pi over 3. And then we have to remember our units are meters cubed. And again, if you want to put it in your calculator to get a decimal, you'll get 134.0 meters cubed. And it's as easy as that, guys. Once you have the radius, it is seriously just plug it in to your calculator, get an answer, you're good to go. All right, these ones are just a little different. These are the ones where you're given the volume and you're going to have to solve for something. So we have the radius of it, we're looking for the radius of a sphere, and it's got a volume of 2,304 pi. So first thing I'm going to do is I'm going to write the formula. V equals 4/3 pi r cubed. This is an important part that a lot of you are still kind of struggling with. This whole thing is the volume. Notice that that volume has a pi in it. All right, so when I write my volume over here, it's not just 2,304. It's 2,304 pi. And then equals my 4/3 pi r cubed. And the first thing I always do on these ones is just cancel the pi out, because there's one on each side, so it can cancel. But if you forget to bring that pi with, it doesn't cancel. So you guys got to be careful there. So 2,304 equals 4/3 r cubed. The only way to get rid of a fraction, guys, unless you want to divide by a fraction, which nobody likes to do, let's multiply by the reciprocal. So multiply both sides by 3 over 4, because then that's going to cancel it out here. And you get 1,728 equals r cubed. Well, the only way to get rid of something cubed, we can't take the square root because it's not being squared. We have to take the cubed root. And so we are going to get r equals 12. If you don't know how to get the cubed root on your calculator, ask me in class tomorrow and we can take a look at it, okay? But if you hit 3 and then you hit second and you hit the one above the square root button, you should be good. But you will get 12 feet. And then we have to take a look at number 4. So with number 4, we want the diameter of a hemisphere. So hemisphere, first of all, we know we're going to need 1/2 the volume, so 4/3 pi r cubed. And the volume is 486 pi equals half of 4/3 pi r cubed. Then we're going to have to start doing some simplifying here, right? I think the first thing I would do is probably multiply these. 1/2 times 4/3, and we end up getting, hopefully you guys agree with me when I say 2/3. So 2/3 pi r cubed is going to equal 486 pi. Again, the pi's cancel on out. Only way to get rid of this fraction that's in front would be to multiply by the reciprocal. So the reciprocal of 2/3 would be 3/2. So multiply by 3 over 2 on both sides. And we get 729 equals r to the third. And again, we can just take the cubed root of both sides. And we get to 9. No, I'm sorry. We get to 9, yeah. Radius equals 9. But then we want the diameter. So we are going to have to double that in order to get the diameter, which means the diameter is 18 inches. Alright, hopefully you guys followed along with that. I know finding the cubed root in your calculator can be weird. I can show you guys that tomorrow. You can also, if you want, take that number and raise it to the 1/3 power. So if you put in your calculator 729 and you put an exponent of 1/3, that's the same thing as taking the square or the cubed root, excuse me. So you can do either one of those and you should be able to get down to your answer. All right. If you have questions, write them down. We can definitely talk about them in class. We're going to do some practice and then we will get you guys ready to do some composite figures after that. All right. I will see you in class. Bye.